Hi students, here we will discuss what is the language of finite automata. Two topics to discuss here: acceptance of a string by finite automata and language accepted by finite automata. What do you mean by language acceptance of a string by finite automata? That means, how can you say that a string is accepted by a finite automata? Suppose we have a string x. Okay, how can you say that this string x is accepted by some finite automata? Consider this example. In this example, there are three states: q0, q1, q2, and two inputs 0 and 1. Then one initial state q0 and one final state q2, and there are a number of transitions in between the states q0, q1, and q2. Okay, consider a string 0, 1, 0, 1, 0, 1, 1, 0. W is equal to 0, 1, 1, 0. Okay, our aim is to check whether this string is accepted by this finite automata. Okay, so we have the transition diagram here. Then we start from the initial state. First, read the alphabet 0. From the state q0, it reads the alphabet 0. It goes to q0 itself. Then from q0, it reads the symbol 1. It goes to q2. Then from q1. Then from q1, it reads the input symbol 1. It goes to q2. Then q2, it reads the input symbol 0. It again goes to q2. Here q2 is a final state, so we can say that this string is accepted by this finite automata. That means we start from the initial state, process the entire given string, and finally we reach a final state. Then we can say that that string is accepted by the finite automata. Okay. So if you have the transition diagram, you can easily travel from the initial state and process all the strings, and finally we reach a final state. We can say that the string is accepted by the finite automata. Okay, how can you write the equation for that? Transition function for that. First we take the string, that means delta cap of q0, 0, 1, 1, 0. We start from the initial state q0. The given string is 0, 1, 1, 0. We put here delta cap, that means here it is a string. Okay, our aim is to process the string from the initial state q0. For this, we start from q0. First we take 0. Okay, first we take 0. That means delta of q0, 0. We know delta of q0, 0 is equal to q0 itself. We get q0. Then next we process delta cap of q0, 0, and take the next symbol also, 0, 1. So here we put a cap, delta cap. So we know what is delta of q0, 0. This is equal to q0. Okay, so this means q0, 1. q0, 1 is equal to q1. Okay, so here we get q1. Okay, then next we take the next input symbol also. That means this one. Okay, so here delta cap of q0, 0, 1, 1. So you know what is the output of this statement? Delta of q0, 0, 1. That means after processing the string 0, 1. Okay, after processing the string 0, 1, you get q1. So that means this output is equal to q1. So from the state q1, you read the input symbol 1, you get q2. q1 you read 1, you get q2. Okay, then next take the next input, that is entire string. Okay, delta cap of q0, 0, 1, 1, 0 is equal to delta of q0, 0, 1, 1, 0. That means you know what is 0, 1, 1. 0, 1, 1 is equal to delta of q0, 0, 1, 1. This one is equal to q2. Then from the state q2, it reads the input symbol 0. You get q2. So we process the entire string 0, 1, 1, 0 here. Okay, you get the output q2. Here q2 is a final state. So we can say that the string is accepted by the finite automata. Clear? So that means a string x is accepted by a finite automata. A string x is said to be accepted by a finite automata. M is equal to q sigma delta q0 f if and only if delta cap of q0 comma x is equal to p for some p in f, where f is the final state. Okay, we have a automata M is equal to q sigma delta q0 f, and our aim is to check whether the string x is accepted by the finite automata. X is accepted by the finite automata if and only if we start the processing, start processing the string x from the initial state q0. So we can write as delta cap of q0 comma x. After processing the string x, suppose we get the output p, and p is a member of f. That means this x is accepted by the finite automata. Okay, that is the acceptance of a string by the finite automata. Next is, what is the language accepted by a finite automata? Language means set of all strings from the input alphabet accepted by the finite automata. The previous example, we know that here we find out, here we have given only one string 0110, and we check that this string is accepted by this automata. Like that, we can find a number of strings accepted by this automata. When you write that strings as L is equal to set w1 comma w2 comma w3 comma etc., then this is the language of this automata. Set of all strings accepted by this finite automata. So language means set of all strings from an input alphabet accepted by the finite automata. This language is called a regular language. That means language accepted by a finite automata is called regular language or regular. Okay. Then we can denote that regular language as L of M, where M is the machine, capital L represents the language. L of M means language accepted by the finite automata M. Okay, so we can mathematically represent that this L of M as set of all strings. Okay, here we say that set of all strings from the input alphabet. So it is a set X. Okay, set of X, such that we have to specify what is X. Delta cap of q0 comma x is in f. That means x is accepted by a finite automata, then x is a language. Okay, set x such that delta cap of q0 comma x is in f. We process the string x starting from the initial state and we get a final state. That means x is accepted by a finite automata, then it is a member of language. Okay, that is the language. Language of M is the set of all strings x that take the start state q0 to one of the accepting state. Okay, that means delta cap of q0 comma x is equal to p, and p is an element of x, or delta of q0 comma x is equal to p, p is an element of x. Okay, so language of finite automata means it is a regular language or regular, and it is represented by L of M. Mathematically, we define the L of M as L of M is equal to set x such that delta cap of q0 comma x is in f. If x is accepted by a finite automata, then x is a member of language. Okay, that's all about the language accepted by the finite automata. Thank you.